Hi, I'm Patrick Reagan. Welcome to Networking Part 10, Introducing DNS. In this video, we'll discuss how DNS is used for name resolution, which is an essential network service for most network services. As always, stick around for the practice questions at the end to test your knowledge and help you prepare for the A+ exam. If you find this video helpful, don't forget to click the like button. If you have not already, subscribe to the Pat Has Your Back channel for more tech training content and technical know-how. Before DNS, host files were used to map human-friendly host names to numerical IP addresses, which can be used to access the host and its services. The disadvantage of using host files is that when you have to add entry for each name and IP address in the host file, and you'll have to update the host file on every system. The host file is a simple text file. In Windows, the host file is located at /Windows /System32 /drivers /etc /hosts. In Linux, the host file is located at /etc /hosts. Comments start with the pound, which causes the system to ignore the line. While host files are not used much today, they come in handy when troubleshooting or testing solutions where you want to override the current DNS on the computer that has the host file. Domain Name System, or DNS, is used to resolve names to IP addresses. When you type in a URL in the browser, or you try to connect to a server or computer, DNS will resolve the name of the server or computer to an IP address. DNS uses port 53. Early DNS used UDP, but more recent versions were upgraded with reliability, security, and privacy, which uses TCP. DNS uses fully qualified domain names, or FQDNs, to map a host name to an IP address. An FQDN describes the exact relationship between a host and its DNS domain. For example, computer1.sales.microsoft.com represents an FQDN. The Computer1 host is located in the sales domain, which is located in the Microsoft second-level domain, which is located in the .com top-level domain. Because it's so closely tied to the Internet and TCP/IP network, it's an essential service that enables the Internet and network to function, and it is required by many network services, including Active Directory. DNS is often referred to as a linchpin service, meaning it's a critical component that, if it fails, it can significantly impact the functionality of other services and the Internet as a whole. Many application services rely on DNS to function correctly. If DNS fails, these services will likely be unable to connect to their servers, causing disruption. If you hear or see naming server, you should think DNS. DNS is a hierarchical distributed naming system used to locate computers and services on a TCP/IP network. DNS clients send queries to a DNS server, and the domain name system receives and resolves queries, such as translating a host or domain name to an IP address. DNS is known as a distributed naming system because the information stored with DNS is not found on only a single DNS server. Instead, the information is distributed among multiple DNS servers, all of which are linked into the hierarchy structure. At the top of the tree is the root zone. The tree can then be divided into zones, each served by a named DNS server. Each zone can contain one domain or many domains. The administrative responsibility over any zone can be delegated or divided by creating a subdomain, which can be assigned to a different name server and administrative entity. In the figure, the zones are Com, Microsoft, Sales. Each has its own set of DNS administrative area that is listed separately from the other DNS zones, although they could be placed on the same server. In this case, Com is managed by VeriSign, but remains under ultimate jurisdiction of U.S. law. Microsoft and Sales domains are managed by Microsoft. Computer1 is a resource record in the Sales DNS domain end zone. The root name servers are the highest level DNS servers in the entire namespace, and they maintain information about the top level domains. After a computer attempts to resolve a DNS name, it begins at the top of the namespace hierarchy with the root name server and works down the levels until it reaches the authoritative server for the domain in which the name is located. All DNS server implementations are pre-configured with the IP addresses of the root name servers because these servers are the ultimate source for all DNS information. They are sometimes referred to as root hints. If root servers change, which is not often, root hints are typically updated when the operating system or device updates to reflect the change and is usually invisible to most users. Just beneath the root name servers are the top-level domains. The original DNS namespace called for 6 generic top-level domains dedicated to specific purposes as follows: com for commercial organizations, edu for 4-year degree-granting educational institutions in North America, gov, which was United States government institutions, mil, which was for United States military applications, net, which is networking organizations, and org, which is non-commercial organizations. Eventually, other domains not tied to a country were added, such as arrow, biz, co-op, info, museum, name, and pro, followed by app, tech, XYZ, guru, photography, and others. While you cannot purchase a top-level domain in the way individuals or organizations buy second-level domains, you can apply to become a registry operator for a new top-level domain, which is a complex and costly process governed by the Internet Corporations for Assigned Names and Numbers, or ICANN. In addition to the generic TDLs, hundreds of 2-letter country code top-level domains exist, named for specific countries in their own language, such as FR for France and DU for Deutschland, which is Germany. 2-letter codes for countries, territories, and other geographic entities are taken from the ISO 3166 standard, which is published by the International Organizations for Standardization. Note, TV is not short for television, but is the country code for Tuvalu, which is a Polynesian island. The TV domain is popular because many correlate TV with the television domain. Each top-level domain has its own collection of second-level domains. Individuals and organizations can purchase these domains for their own use. For example, the second-level domain, Contoso.com, belongs to a company that purchased the name from one of the many internet registrars now in the business of selling domain names to consumers. Other examples include Microsoft.com, Intel.com, Wikipedia.com, Facebook.com, and YouTube.com. For the payments of an annual fee, you can purchase the rights to a second-level domain, and if it's available and not already taken. After you purchase the rights to a second-level domain, you can create as many hosts as you want in that domain by creating new resource records on the authoritative servers. You can also create as many additional domain levels as you want. For example, once you own the Contoso.com domain, you can create the subdomains sales.contoso.com and marketing.contoso.com, and then populate these subdomains with resource records such as www.sales.contoso.com and ftp.marketing.contoso.com. The only limitations to the subdomains and hosts you can create in the second-level domain are as follows. Each individual domain name can be no more than 63 characters long, and the total FQDN, including the trailing period, can be no more than 255 characters long. Every time a client needs to perform name resolution, the client checks to see if the name queried is itself. The client then searches a local host file, which is a list of IP addresses and names stored on the local computer, and then looks for cached DNS records. The DNS record time to live has not expired, it will use the cache value. The computer will often cache resolved addresses to improve performance by reducing the need to repeatedly query upstream servers for the same hostname. Even DNS servers will cache resolved addresses to improve performance. Domain name system servers are queried. Primary, secondary, which is used for redundancy, only goes to secondary if the primary DNS is not available. When it finds an active DNS server to query, the cache of the DNS server will be checked. If it's not in the cache, it will perform a direct search in its own database. If the DNS server does not already know the answer, your primary DNS server will do an iterative query to find the correct DNS server. When the query is completed, the response will be added to the DNS server cache and the DNS cache of the client. Cache value will remain until TTL of the record is reached. The client queries the first DNS listed in the IP configuration, and the DNS server is not available, it will go to the secondary DNS server if one is listed in the IP configuration. The second DNS server is not available, it will go to the next one if one is listed. It is recommended to have at least 2 DNS servers listed for redundancy. If it queries the first DNS server and the DNS server is active and does not know the answer and cannot determine the answer through iterative queries, it will respond with no host found and will not query the second DNS server listed in the IP configuration. Again, it will only go to the secondary DNS server if the first DNS server is not available, not because it does not know the answer. DNS zones can be divided to the following types. The forward lookup zone maps the domain name to an IP address. Forward lookup zones are the basis of what DNS servers do and are used for accessing websites, email services, and more. Reverse lookup zone maps an IP address to a domain name. Reverse lookup zones are useful for security and network troubleshooting and are often used by email servers to verify the authenticity of incoming emails. The forward lookup zone will have the bulk of the records and record types including A, Quad A, CNAME, text, and service records. Besides the SOA and NS records that are required for every zone, the reverse zone only contains pointer records. The resource records, or RR, is the unit information entry in the DNS zone files. Resource records are the basic building blocks of host name and IP information and are used to resolve all DNS queries. Resource records come in a fairly wide variety of types in order to provide extended name resolution services. Examples of resource records include SOA, NS, A, Quad A, CNAME, pointer, text, and service records. The most common DNS resource record is the host record, or A record, which provides name resolution to IP address. Common resource records include the following. The start of authority, or SOA record, define parameters for the zone, include the name of the primary name server. The name server, or NS record, specifies the name or DNS servers for the domain. A is the IP version 4 address record that is used to translate from name to IP address. Quad A is IP version 6 address records that are used to translate from name to IP address. Pointer records are used to translate from IP address to name. It's found in the reverse lookup zone. The mail exchanger, or MX, is used to find the mail servers for a domain. And the text contains information about your domain. A DNS host record, also known as the A record or address record, is a fundamental type of DNS record that connects a domain name to an IP address. The A record is found in the forward lookup zone and is the most common DNS resource record. The A record only holds IP version 4 addresses. Websites with IP version 6 addresses uses a Quad A record instead. The default time to live, or TTL, for an A record specifies how long the record will be used before being updated. This means that when you look for a site and it gets the IP address for that site, it will cache in your system for the number of minutes specified in TTL. It will not look at the record again until that time has expired because the value is cached. The maximum length of DNS records is 255 characters long. A DNS pointer record, or PTR, is a domain name system record that associates an IP address with a domain name. Pointer records are the opposite of A records, which associates a domain name with an IP address. Pointer records are also known as reverse DNS records. They're only found in the reverse lookup zones. Pointer records are used to verify that the IP address corresponds to a domain name, which is a common step in determining the legitimacy in the connection's origin. This is especially important for email servers, where properly configured pointer records can help prevent legitimate emails from being marked as spam. IP version 6 pointer records are stored under the .ipr6 ARPA namespace instead of ARPA. CNAME is short for canonical name, is used to alias one name to another. For example, if you have example.com and www.example.com pointing to the same website or application, which is hosted by the same server. The server's IP change, you update it once in the A record, and the alias automatically reflects the change, and it reduces the risk of misconfiguration by avoiding data duplication. CNAME records are commonly used to redirect multiple domain names to a single website or server. For example, you might have olddomain.com redirected to newdomain.com using a CNAME. You can also alias a server hostname to an external provider such as mail.example.com to ghs.googlehosted.com. A DNS MX record, or mail exchange record, is a type of domain name system record that specifies which mail service is responsible for receiving emails for a domain. MX records are essential for email delivery because they tell sending email servers where to route messages. MX records point to domain's mail server or spam email filter service. If email is sent to the spam email filter will forward to the mail server. A DNS service record is a resource record that specifies the location of servers for specific services, such as the location of LDAP or domain controllers, voice over IP or VoIP, and instant messaging. Service records are different from other DNS records because they include a port number in addition to the server or IP address. It identifies computers that host specific services, such as domain controllers for Active Directory. It includes service name, protocol, port number, priority, weight, and the target domain or server, which will direct client applications to the appropriate servers. Service records can point to either an A record in IP version 4 or a quad A record in IP version 6. Here's an example of service records that specify the location of global catalogs, Kerberos logon servers, change password, and LDAP servers. In other words, this is used to find the domain controllers in Active Directory. Notice that Kerberos protocol uses port 88 and LDAP uses port 389. A SIP server, or Session Initiation Protocol server, is a network device that manages and routes calls for businesses that use VoIP phones. DNS service records can be used by the clients to locate the SIP servers. Examples of the SIP servers are shown on the screen. This record indicates that the server name sipserver.example.com is listening for SIP services on TCP port 5060. The priority is 0 and the weight is 5. A DNS text record is a text-based resource record that can be used for a variety of purposes, including domain ownership verification. By adding a specific text record specified by a vendor, proves to the vendor that you own or control the domain, such as Google, Site, and Apple verification records shown below. Email security to help prevent phishing, spam, and other malicious activity. And general information that can be used to provide human-readable information about a domain, such as contact details. Spam management uses the following DNS text records. The Sender Policy Framework, or SPF, is a type of DNS text record that lists all of the servers authorized to send emails from a particular domain. If email comes to the server that is not on the SPF record, it can be marked as spoofed by the receiving email server. DomainKeys Identified Mail, or DKIM, digitally signs a domain's outgoing mail, which is validated by the mail server. It's not actually seen by the end users, as it happens in the background. The receiving email server would use a public key found in the DKIM text record to verify that a message was sent from a particular domain and that the message was not modified. Domain-based message authentication, reporting, and conformance, or DMARC, is an email authentication protocol that configures a policy. It's an extension of SPF and DKIM that lets recipients that they should do with the emails that don't validate through SPF or DKIM. The policy is written in a DMARC text record that may include accept all, send to spam, or reject the email. You usually only have one SPF record, which is limited to 255 characters. You can only have one DMARC record. You can have multiple DKIM records, which is used if you have more than one server sending emails, including the organization's email server, web servers that send emails on behalf of the organization, and any mail service such as those used in mail campaigns. Question: which file is used to map host names to IP addresses on a client computer? Answer: hosts. Question. Today, what service is used to provide name resolution to an IP address? Answer, DNS. Question. When you type in a URL, what is the full name called? Answer, fully qualified domain name, or FQDN. Question. What port does DNS use? Answer, 53. Question. Which of the following is the DNS feature that controls how long a lookup is stored in cache on a server? Answer, TTL. Question. Users unable to navigate to a website because the provided URL is not resolving to the correct IP address. Other users are able to navigate to the intended website without issue. Which of the following is most likely causing this issue? Answer, host file. Remember, local host files are used before DNS cache or DNS queries. Question. You're moving your mail server to the cloud, and you need to ensure that the new mail server will receive email. Which of the following types of DNS records should you update? Answer, MX. Question. You're setting up DNS records on local servers for the company's cloud DNS to enable access by host name. Which of the following records should be used? Answer, A. Question. What type of record is used to specify which are legit servers that send emails for a domain? Answer, SPF. For more information, refer to these sites. In summary, before DNS, host files were used to map human-friendly host names to numerical IP addresses, which can be used to access the host and its services. While host files are not used much today, they come in handy when troubleshooting or testing solutions where you want to override the current DNS on the computer that has the host file. Domain Name System, or DNS, is used to resolve names to IP addresses. DNS uses fully qualified domain names, or FQDNs, to map a host name to an IP address. DNS is a hierarchy distributed naming system used to locate computers and services on a TCP/IP network. Root name servers are the highest level DNS servers in the entire namespace, and they maintain information about the top level domains. The resource records, or RR, is the unit information entry in the DNS files. Thank you for watching this video. The next video will be networking, part 11, network services. If you like this video, don't forget to click the like button. If you have not already, subscribe to the Pat Has Your Back channel. Thank you.